I think it's important to say that there aren't different rules of the game in the subatomic world and the world that we observe, this world of common sense, let's say, that we perceive. And it's pretty well understood, I would say it's well understood, how the world that we see emerges from this rather strange but well-defined behavior that we see in the subatomic world. And it's not only the subatomic world, by the way. We have an increasing number of quantum technologies that are really based on this behavior, the quantum computers being a good example. And so you see that this is not just something that you can say, well, we don't need to think about it really because it's in the world of atoms, because we're using that behavior now in technologies. And so it really does become an important theory to try to understand.
Why is it important that we seek to solve the mysteries of quantum physics?
You could argue that even today, the interpretation of what the theory is telling us about the nature of reality itself is not universally agreed upon. One of the big changes actually that's happened in teaching quantum mechanics in universities over the last few decades is that it was always, when I learnt it, so back even in the 1990s, it was common to teach it historically. So you go through the things that we've talked about. You go through the photoelectric effect and the structure of atoms. You get to Niels Bohr and his early explanations of how atoms might work, following on from Ernest Rutherford in Manchester detecting the atomic nucleus. And then, so this idea that an atom is a nucleus, a dense positive charge. It wasn't known exactly what the structure was at that time, with the electrons, let's say, orbiting in inverted commas around it, so that there's a picture of almost like a solar system, but it was known that doesn't work because you have charged particles moving in the vicinity of other charged particles, and that means that they radiate and they would not be stable. And so there's all these things going on, confusion, and then Bohr suggests that electrons can only take certain energies, which we now call orbitals, around the atomic nucleus, and all this stuff is going on. And it used to be that we would teach it like that in university. But if you do that, you pick up all the confusion, the confusion, decades and decades of confusion that these great physicists felt in trying to come to terms with this counterintuitive picture of the world. So now, I think it's more common in universities to start with the theory as we understand it today and just say, well, this is the way the world works. And perhaps the best